1, 2, sound check, 1, 2. What's up? Are you good?
Away, sir.
Oh, away. I'm sorry, guys. I'm on campus, so I was searching for a free venue. So, I was all over the place. I was all over the place searching for a free venue. That's why I had to take some time, So I was searching all the labs. Anyway, I just found a corner to, yes, what's up, guys? Gabriel James. All right. Okay. Ibrahim Gabru. I'm good. Yeah. Okay. Session is being recorded. That's good. Mic is good. All right. What else? Visual Studio. I need to sign in. Okay, let me just sign into my Visual Studio. All right. I connect. Okay. All right. Oh, in error is okay. Script, blah, blah, blah. Do you want to put your running scripts on this page? Let's continue. See. Passwords. All right. Okay, I think it's all good. Additional resources for the lecture. Where are they? On the Google Drive. Let me just log in, indicate some resources, collections. There we go. Cool, got it. All right, additional resources loaded. Visual Studio. Okay, still signing in. All right. Okay. Right. Okay. So, okay, share the screen. Where are we? Share the screen.
Hi, sir. I just wanted to ask if we plan to go for the full 2 hours because I have to go to the dentist just before 12.
Sorry?
So I was just wondering if you were planning to take up the full 2 hour session because I have to go to the dentist just before 12.
No, I won't. You know me. Normally, I just take 1 hour. Then the last hour, I give you something. Normally, I just take the first hour.
Okay, cool, perfect. So yeah, because I didn't want to miss anything and then I'm at the dentist and then I don't know what you did.
Okay, no problem. Okay.
Oh yeah, you're right.
Right. Yeah, and there's a recording just in case. Okay. Okay, I was about to share the screen. Okay. All right.
Cheers, Marcelo.
Share application. Okay. Okay. So it means I've got group 1 and group 2 guys in this meeting. Can I see those on group 2? Just raise your hand if you're group 2. Just raise your hand. Group 2 guys. Oh, I can see there's Dale there. Okay. All right. There's Dylan. There's else. Only 3 group 2. Okay. All right. Ronaldo, Darren. Okay. All right. Okay. Oh, it's maybe some will join in later on. Okay, but no problem. They can also catch up on the recording as well. So I think I've seen the topic. Let me see. What's happening with my Visual Studio now? It's playing games. The extended trial is expired. Oh my goodness. This place, what are they doing on campus, huh? They're saying
That's not
my
good.
Visual Studio is expired. Oh my goodness. Oh, what can I do? Maybe I will relocate to another machine quickly. Oh my God, these people, they're busy playing games. How can they say Visual Studio? I thought it was fixed. Last week I did the same problem. I had the same problem again and it was solved. See now. Oh my goodness. Just a minute, let me look onto another machine. Okay. Okay, so that's our topic collections. That's our topic collections. Collections. Right. One, so basically, it's a recap of something which you've done already. You are familiar with this. You're familiar with these collections. So I think just a few things which I just want to point out as you prepare for your what? As you prepare for your task one. As you prepare for your task one, just a few things to point out. Then I know you'll be good to go. I know you'll be good to go. So that's why I wanted to load my Visual Studio, but now this machine is doing something else. Okay, I will relocate. Okay. All right. So I think you're still familiar with this. What is a collection? It's a set of similar typed objects that are grouped together. Okay. Then the benefit is that they standardize the way groups of objects are handled by your programs. So that's our course for this semester. We are looking at what data structures and algorithms. Data structures and algorithms. So a collection is also a structure. Yes, collections are data structures that holds data in different ways for flexible operations. So the C# collection classes are defined as part of the system of collections or system of collections or generic namespace. Okay, we look into this. Okay, then most of the classes implement the same interface. I think I mentioned this, or if I forgot, but all of them, they implement the IEnumerable. interface, then iCollection, then iList. So most of them, they implement the same interfaces. Of course, we can have variations here and there, but most of them, they implement the same interfaces. You find the same methods to add, the same methods to delete, the same methods to read. Okay, right. Okay, let me see. Visual Studio. Just a moment. I'm trying to Visual Studio on the machine. Oh, Visual Studio on the machine. Okay. So, all right. Types of collections: generic collections and non-generic collections. Normally we talk about this. To specialize, it's very rare to talk about it. Normally we look at what? Normally we look at generic and non-generic collections. That's where we end. Maybe when we go to honors, masters, then we talk about what? We talk about the honors. But for now, on generic and non-generic, you're good there. You are sorted there. Okay, just I'm looking onto the machine, Visual Studio, checking is perfect. Okay. Create a new project. Okay, I think there's something wrong with the network again on this campus. It's like it's holding up. It's holding up. The network is like holding up. Right. So of course, our syllabus specify that we look at generic collections. Our syllabus specify that we look at generic collections. So I'll just pass through non-generic collections, since most of you guys were complaining that you don't have a strong background with advanced C#.
Sorry, sir, you cut out just before you finish your sentence.
Okay, right, just a moment. I'm looking to another machine. Right, let me just log off on this machine. Let me just log off on this machine and move to another machine. The other machine is ready. So let me just log out, then I'll rejoin. Let me just log out and I'll rejoin using another machine, the one which has got Visual Studio. Okay. So one, two, sound check. 1, 2, sound check. 1, 2. But can you hear me?
Yes, sir.
Okay. Oh, I've relocated to another machine which has got Visual Studio, because I don't like talking for the whole hour. Talking is not our business. We need to have some action. Okay, there we go. All right. Yes, this machine is much better now. Okay. Okay. So I was saying something. I still remember I was saying something. Let me just get the slide which I was using. Just get the slide which I was using. Okay. Let's collect my slide. So I was saying, I wanted to assume that we all did generic collections, but I realized that most of the guys' background in advanced C# is not good. So I just said, let me just consolidate the facts once again, so that at least we are at par. We are at par. We are on the same level. Those who did very well and those who didn't do at all, then at least we are on the same page. So I was talking about that most collections they implement a common interface. Most collections they implement a common interface. Actually, all collections they belong to the what? All collections they belong to the IEnumerable interface. They belong to the IEnumerable interface. IEnumerable is like the parent interface. Then from the IEnumerable, we've got I collection, then I collection, then we've got the I lists and other various other collections. But basically, what are we looking? We are looking at what? A set of similarly typed objects together. And what are these? These are data structures. Which we use also in C#. And maybe to get a better understanding of this, you start from the arrays. Then an array is a structure. It's a strongly typed. Why? Because in an array, you just store one type. If it's int, it's int. If it's string, it's string. Okay. So collections are also in the same category. Of course, collections they are subdivided into two groups, major two groups: generic and non-generic collections. So initially, with the introduction of C# 1.0, the non-generic collection, with the sort of the .NET Framework 1.0, we had the non-generic collections, which means in this one you can store any kind of element. It's a non-generic. So I'm just showing you this in case, but our course is focusing on generics. Why generics? Because generics they are what? They are type safe. They are type safe. So okay. So this is just a what? This is just a demo. Generics demo. Okay. Right. Okay. Do you have a Visual Studio? Can you confirm a visual?
We're using .NET Core, right?
Yes. Can do the same thing, but I think this one is .NET Core, and this is a console application. It's a console application. Okay, then we just increase the font to 200. There we go.
Sir, I just wanted to say on the newer versions, unlike the updated Visual Studio, it seems like it's just .NET, not .NET Core anymore. Because my friend tried to create a .NET Core app, and it was just he could only see .NET. He didn't have an option for .NET Core.
You don't see the framework and all those kind of things. Yeah, I think it's
It
being
still has the
upgraded because the framework. Well, the framework is, I think, it's now old. The framework is now old. So we now have these latest ones. I'm not sure. I heard that the Visual Studio 2022 is out, but I have to find out how does it look like. I think it's way much better. And I think all some of these things like Windows Phones, I think they won't be there because these are traditional things, Windows Phones and what. But now you have UWP, Xamarin, and what all these kind of things. So I think a lot is happening in .NET, Microsoft. All right. Thank you so much. Okay, so there we go. So I say traditionally we're working with what? We're working with the .NET 1.0, which only worked with what you call the non-generic collections, and non-generic. You're saying these are not specialized, or these are not like these are not strongly typed. That's the technical word we should use. They are not strongly typed, which means you can collect, you can store any type of data. You can store any type of data. For example, we can talk of this array list. This array list. Okay, talk of this. It's a non-generic collection. Talk of this array list. I'm just doing this in case some of you guys you may want to use it for your what? Array list is not appearing. Our namespace, yes, something is missing there. Using system dot collections. That's our namespace, using system dot collections. And let's try again. Array list. There it is. There it appears now. Array list. Array list AR is equal to new what? Is equal to new array list. So that's a collection, right? That's a non-generic collection. That's a non-generic collection. Non-generic collection. Why are we saying this? Because it can store. Is it my mic or someone's microphone? Just say the funny sound. Is it my mic or it's someone's microphone? Someone's being disconnected. Okay.
Darren
All right.
Raise his hand.
Okay. Or it's Angela Bay. It's Angela's base mic. Darren. So there we go. This is what? This is a non-generic collection. Why non-generic? We can store any type. Any type. For example, we've just declared this. So declaration, instantiation. So let's just add some elements into this one, into this non-generic. So AR dot add. Remember what you said. Most of them they implement the same the same interface, the same methods actually. Most of them they implement the same, like add. Any collection you need to add some elements. You can add, you can remove some elements. You can do some other things like sorting and what, but most of them we have the same you have the same operations. Okay, so there we go. Control D. So that's the first type. Then the second type. I'll just put my name. Okay, semicolon there, semicolon. Then the third type, let me put another something there. Then the fourth type, let me put something there. Okay. So there we go. All right, there we go. Cool. So it's non-generic in the sense that check on the first element. It's a what? The first element is a what? It's an int. It's a structure. It's a struct int 32. It's an integer, right? Then the second one is a what? It's a string, it's a class. So the first one is a struct, right? It's an int. Then this one is a what? It's a class, string class, right? So it's a string. Then this one is a what? It's a double. It's a struct, it's a double. It's a struct, it's a structure, it's a double. Then this one is a what? Struct, it's boolean. So you can store any type, any type. You can store any type into what? Non-generics. You can store any type. It's not what? It's not type safe. It's not type safe. Why? Because all the types can be what? Can be stored in one collection. But at the same time, you can take advantage of this depending on the application. Sometimes you can just use an array list. Like if you want to show like a record maybe of a student, you want to show the name, what, all those different kind of. We still use it. We still use it, but it's a traditional thing. It's a traditional thing. So it's so in this case we've got what? We've got this array list. Let me check at the types which we have. What else do we have in this? We've got the array list.
Sir, before you move on to ask a question, please.
So there's a question.
Yeah, I just want to ask: are there any generic implementations of the array list? For example, if you want to get the constant time of an array list, but you would like to have it be strongly typed.
You don't use the term array list now. You just use list only. You just use list. Then you declare your own.
Is a list structured the same way as the array list?
Exactly. Yeah, the list.
Is that okay?
Yeah. Then you now others. We can have others as well. Like in this case, we can have what? We can have like the queue. The queue is in both. This is also in both generic and non-generic. Stack is also there. For instance, you can have a what? You can have a stack of what? You can have a stack of non-generic like this one. You have a stack st is equal to new what? Is equal to new stack. So you have a stack in what? In non-generics like that. You can have a stack in non-generics like that. And you can it's also found in the generics as well. Okay, it's also found in the generics as well. Okay, so so there we go. So these are what? Non-generics. These are non-generics. I think we've seen the list there. The array list, the hash table, the queue, sorted list, the stack. So these are like traditional. These are like primitives in as far as collections are concerned. But they belong to the what? To the collections what? System.collections namespace. System.collections namespace. Okay. Then we've got the what? We've got the generic collection. We've got the generic collection. We've got the generic collection. There we go. So this one it uses the what? Another library as well, system.collections.generic. Otherwise, it won't work. Like in this case, we've got our public class program. Let's say we now want to use a what? Let's say we now want to use a stack, the one which is what? The one which is type safe. The one which is type safe. So there we use this Angular brackets to declare type safety. There. So this we now want to have a stack of integers like this. You see, it will not work as long as you don't have that namespace using system.collections.generic. It will not work unless and until you add that dot generic. Dot generic. There we go. You see, the error is gone. The error is gone. But on the array list now, you see now on the array list, let's see your point. You're saying, can we have a strongly typed array list? Let's try. I haven't used. Let's try, but I haven't used it. Let's try if you can have a strongly typed array list, but I haven't used this. Let's see if we have a strongly typed array list. Let's say of string strongly typed array list of string. Let's see. Array list of string. It's not defined there. It's not defined. It's not defined. So it has to be a what? It has to be a what? It has to be a list. It has to be. It has to be a list. It has to be a list, and all these types, they are now wrong. This integer is now wrong. Why? It's now strong. So when you say it's strongly typed, like, in case you missed that, guys, it's strongly typed. You say it only contains the type which you declare. Like this one, it's only expecting a what? A string. You see, a string. Or this one, the int, the double, the boolean, they cannot go through. They cannot go through. Then the stack of int is only integers only. st dot what? st dot add. st or stack we don't add, what we push. On a stack we push. st dot push. Okay, we are pushing only integers. We are pushing only what? We are pushing only integers. Control D, Control D, Control D. Yes. We are pushing only integers. Any other funny type, it won't go through. Anything else, it will not go through. Anything else will not go through. Why? Because it's type safe. It's type safe. It's type safe. It can only take that type which you've declared. It can only take that type which you've declared. So that's type safety. So collections.generic is type safe. So these are the ones which we are using for our task one, right? Our task one, we're using what? For our task one, we are using type safe collections. Type safe collections, which are generics. Type safe collections, which are generics. That's the one. These are the ones which you are using. So I just wanted to make these things right in case some people missed this in the last year advanced C#. Yeah, this is part of second year. This part of second year C#, of course. We're now bringing it back in terms of structures. So these are like what? These are like what of the first lecture? Just remember the first lecture. Those who still remember the first lecture, yes, those who still remember the first lecture, that we've got different types of what? We've got different types of data structures. Yes, we've got linear, we've got non-linear. Yeah. So we've got these different types, and these are constituting part of our syllabus. Much of our syllabus is what? Much of our syllabus is based on this. Much of our syllabus is based on what? Is based on these. Is based on these collections. That's what we'll be doing for the rest of this semester. That's what we'll be doing for the rest of this semester. Of course, it's not that interesting. It's kind of boring. Maybe I'll try to get something interesting from you guys. Maybe those guys who have joined the hackathons, maybe we can have some of those things. Otherwise, our syllabus is so boring. Our syllabus is so boring. We need to do something else because we cannot. Can say we cannot spend like the whole lecture talking about the stack. This is the stack. We push, we pop. What else? No, not at this level. Not at this level. But you are going to apply this. You are going to apply this. What? You're going to apply this in your what? In your task one. Remember, if you missed that, the presentation, I think there's a link. There's a link on OneDrive. There's a link on the POE briefing. There's a link. We spoke in depth about what you're expected to do in your task one. Like task one, they're required to use the what? They're required to use a generic. They're required to use a generic for storage. So it's not specified again what you're going to use. So which means you can choose either you want a list, either you want your own user-defined list. You want your own user-defined list like this one. So you can go right-click there, add, right-click, add a class. I'm just trying to create another class. Okay, I'll just create a student class. You want to have your own what? You want to have your own list. You want to have your own list with own, which is strongly typed. That's the advantage. Your own list which is strongly typed. So I want to have the type of students. Type of students. This for the student. So the properties for the student. Provide int what int student ID. I need an ID. Then control D, student ID. I also need student name, which is a string. The student name, which is a string. Then I need gender. I need gender, which is also what? Which is also strict. Type this. So I'm trying to build my type safety here. I'm having my own user defined list. I'm having my own user defined. I'm having my own user defined lists. So let's just declare my list public static list. You see, list there. We have got what linked list node, list, I list, blah blah blah, sorted list. Okay, so which means you want to declare your own list. Because of suggestions already. Why? Because you're using the system.generic, system.collections.generic. So there we go. I need a list of type what? I need a list of type students. My list is of type. My list is of type what? My list is of type student. Then the method which is used by the IEnumerator to enumerate these students, I think it's get what? Get students. It's get students. Let's take the suggested one, get students. Yes, that's the method which I'm going to use to operate on the what? On this list. Right, okay, there we go. Then I declare my lists. My list. This is a what? It's a list of students. It's a list of students. Then the object for the students is equal to new what? Is equal to new. Where is my list? Is equal to new. New list. There we go. Is equal to new list. There we go. Is equal to new list. There we go. Right. Then the what? Instances of this student. Okay. I want to have a list of students. I want to have a list of students. Okay. I want to have a list of students. Then students. Then first student. First student. Student one. Then one is equal to what? Is equal to new. Is equal to new student. New student. Constructor. Let's construct this new student. Let's use let's use anonymous types. Anonymous types. Name. So the first one is ID. ID. Okay. ID is equal to 101. You put a comma if you're using anonymous types. You put a comma there. Okay. The name is equal to. Let me put my best. under comma, then name, then gender is equal to there we go. Right, we put no comma here. We now put a semicolon. There we go. So it's a list. You can create your own list. You can create your own list. You can create your own list of what of type, of whatever type. Then we add this student to the what to the list. We add this student to the what to the list, which is our list. Students dot add. What are we adding? Our student one to the list. We're adding our student one to the what? Student one to the list. There we go. Student one to the list. So you want as many students as you can. There you go. Control C. Control V. Control V. As many students as you want to have. Student one. This is student two. This is student three. Then add student two here. Add student two. Add student three. There we go. So then there's one error there. Let's return the what? Let's return our type. Return students. There we go. So what's that? This is a generic list. This is a generic list. It's what? It's user defined, but it's what? It's type safe. It's type safe. Why? Because it's only going to capture what? It's only going to capture what? It's only going to capture ID, int ID, string name, and gender. It's only going to capture this int ID, string name, and string gender. So it's also type safe. It's also type safe. So it's up to you. It's up to you. Whatever you want to use, it's up to you. It's up to you. It's up to you. Whatever you want to use. It's up to you. Whatever you want to use. Okay. So so these are what? These are generics. These are generics. These are generics. These are generics. These are the generics. Let me check on the types which you have for the generics. What do you have? Do we have types? Do you have a list of the types? Generics. It's like we don't have a list, but I think it's also. Let me check on this table. On this table, we've got the link. We've got the dictionary. We've got the linked list, the queue, sorted dictionary, sorted list, the stack. These are the what? These are the implementations of the what? These are the implementations of that generic collections. So for your task, I think for task number one, I'm not sure. Some people were talking about using the linked list. Some people were talking about using the linked list. It's up to you. But for task number two, you're required to use a dictionary. Task number two, you're required to use a dictionary. Task number two, you're required to use a what? To use a dictionary. What is a dictionary? A dictionary is a what? Is a key value-wise pair. A dictionary is a key value-wise pair. A dictionary is a key value-wise pair. Key value-wise pair. You declare your dictionary. Declare a dictionary. There you go. Declare a dictionary. It's a key value-wise. Key value. You declare the key and you declare the value. For the key pair. Key pair. Then let's say DC is equal to new what? Is equal to new dictionary. Is equal to new dictionary. You declare the key value what? The key value pair. It's also type safe. It's also type what? It's also type safe. Key value pair. You declare the key value pair. Let's, for example, the books in the library. The books in the library, they've got an ISB number, which can be an int. Then they also have the what? The book what? The book title dictionary. So they have this one. This one is string. Then you can have again int and string. There we go. All right, why is this one underlined? I'm not sure. Key value. Okay, or it's in the same bracket. Okay, it's in the same bracket. Just put a comma. It's in the same bracket. Just put a comma there. There we go. So that's a dictionary. Key value. This is the key, and this is the value. So this can be the student number. For task 1, we are using a what? For task 1, we are using a list. Remember, you're only required to do the sorting later on using the sorting algorithm for task 1. But for task number 2, we're going to use a dictionary for storage key value. I don't know what you're going to store there, but you're going to store some elements. Then that's the dictionary. Then for task number 3, I'm not sure what you're going to use. Task number 3. Number 3, you're going to use a tree. Number 3, I'm going to use a tree. Number 3, I'm going to use a what? I'm going to use a tree. What? I'm going to use a tree collection. So these are the what? These are the generics. So that's what you are required to know. And you have this that you're going to use them for your what? You're going to use them for your. You're going to use them for your what? For your task 1, task 2, and task 3. Okay. Are there any questions? Are there any questions?
No.
So what
I'm thinking
value
of
did you
doing-
return on the class file?
Sorry.
What value did you return on the class file?
On the class or this one, I just returned the what? I just returned the what? The list of what? The,
Oh, just students. Okay, thanks.
yeah, that object exactly. That's the one which I returned. Well, that's the type which I taking now. This student, so I return this. Okay. So if there are no questions, can I give a new ICE task? I'm thinking of what now? No, let me not do that now. Now I want you to focus on your task 1. Now I want you to focus on your task 1. Since you now have this knowledge of list and what, I want you to focus on your task 1 for this. Then you implement this. You know what? You implement this on your task 1. You choose the list. You implement it on your what? On your task 1. Implement it on your task 1. I trust you that you guys are now serious. I trust you. But second years, I want them to do a prototype. Second years, I want them to do a prototype. But you guys, were third years. You are mature. I won't push you to that. But I trust that you are now mature. So start working on your task 1. Start working on your task 1, implementing any list from that list of the generics. Any which one is advantageous. Some people are talking about the list. It's up to them. Okay, so that's your task 1. That's your task 1. You're going to implement any list. Then those core numbers, they're going to be sorted, number 1, and they're going to be randomized as well. Okay, that's task number 1. Okay, so if there are no questions, let me release you now. Then we meet each other tomorrow. Tomorrow, what are we looking at? Tomorrow we are looking at I think virtual methods. Tomorrow we're looking at virtual methods, visualization, virtual methods. Then we'll go for the break. When we come back, we start on vacation and something else. So yeah.
Is this tomorrow on campus, sir?
Tomorrow it's on campus, exactly.
Okay, cool.
So all right. Take care, guys. Thank you so much for your patience.
Is there anything you wanted us to do now, activity-wise, or nothing?
No, I want you to focus on the task 1 for the POE. Just begin the process, just begin the process,
yeah, I've already
try
started.
to understand exactly.
All right, cool, sir.
Do the class diagrams, the system design, trying to understand the problem, those kind of things. Then we'll see each other tomorrow.
Cool, sir. Cheers, enjoy your day.
Okay, sharp, same to you. Cheers, guys. We'll see each other tomorrow. The rest of the day.
How do I leave?
Want to leave?
I forgot how to. I won't lie. Oh, there.
Are you
Okay,
checking?
Cheers, sir.
You found it now?
Yeah.
Okay, cool. All right. The recording for today's class, recording, what I'll do, I think there's a link which I created on OneDrive. So I'll
Just forward
download then I'll,
the link onto Teams, so the OneDrive link, and then we can just
Okay.
access the. We'll just
okay,
access
no problem.
the
I'll do
sessions
that.
there.
I'll do that. I'm not sure. I think it was I think I forwarded it, but if it's not, I'll just forward.
Cool, sir. So it says.
Take care.
Sir,